So we'll start our new lesson in permutation and combination. So the first problem is in how many ways a cricket team of 11 can be selected from 17 players in which 5 players can bowl. Each team should have at least 2 bowlers. So this is clearly a combination problem. So we will see the first part of it. In how many ways a team of 11 can be selected from 17 plus one portion in which 5 players can bowl. Each team should have at least 2 bowlers. So how we do this problem? First, we will take minimum 5 bowlers. Each team should have at least 2 bowlers. So out of 7, see what is record from? 17 players in which 5 players can bowl. So bowlers are only 5 totally. But each team should have a minimum of 2 bowlers. So we will deal with the bowlers portion first. So out of 5 bowlers, 2 are to be selected. At least. So 5 combination 2. So if there are totally there are 17 players. So if your bowlers are removed, now out of rather remaining 12 players, 9 are to be selected. So it is 9 to 12 combination 9. What about 5C2? What is 5C2? 5 multiplied by 4 divided by 2 multiplied by 1. So is equal to 10. What about 12C9? So we have seen the formula, 12C9 means 12 multiplied by 10 multiplied by 12 11 should be 11 and then 10. 12 multiplied by 11 multiplied by 10. Remember even factorial 9, they will get cancelled. Here now factorial n minus r, you should get 3 multiplied by 2 multiplied by 1. You try using the formula. How you are using the formula? Factorial n divided by factorial r multiplied by factorial n minus r. Factorial r is here. R is equal to 9. So factorial n by factorial r is equal to 9 factors will go. So 10, 11, 12 is coming in the numerator. N minus r is 10. 12 minus 9. Factorial 3 is 3 multiplied by 2 is coming in the denominator. So you cancel the common factors. 3 4s are 12. 2 2s are 4. 2 multiplied by 11 into 20. 10. It is 220 ways. So Bowlers can be selected in 10 ways. Remaining players can be selected 220 ways. So cricket team, what is the cricket team? How many ways a cricket team can be selected? Team can be selected in 1 multiplied by 2. It is 10 multiplied by 220 is equal to 2200 ways. That is the answer. So we'll move to next problem. So in a university, students can choose 6 courses out of 9 courses available. And if 2 courses are compulsory, in how many ways the students can choose? So out of 9 courses, when 2 are compulsory, so you've got remaining 7 courses. So in how many words? So students has to choose and 3 more course is to be selected because 2 courses are compulsory. So number of ways courses can be selected is equal to 7c 3 ways is equal to 7 multiplied by 6 multiplied by 5 divided by 3 multiplied by 2 multiplied by 1. So cancel common factors is equal to 35 ways. So if you see the combination number of ways are less because it are grouping 2 courses. You don't name each and every course, make it the same order and all. This is a combination. So there is a difference between permutation and combination that we have to remember always. Which is permutation? If it is a particular order, then it is a permutation. Next problem. If there are 6 periods in which each working day of a school, how many ways can one arrange 5 subjects such that each subject is allowed at least 1 period? A many period, whatever it is, doesn't matter. So out of 6 periods, so 6 periods equal 5 subjects that we have to remember plus 1 subject is repeat. So it does not matter what is that. That is not specified in the problem. So the number of ways it can happen is equal to five P5. So the number of ways is 5 subjects coming is 5p5 multiplied by what about this one's arbitrary subject? It can be anything. So this also in 5 ways you can arrange it. So there are totally 6 periods, 5 subjects. This is sixth hour. This can be arranged in P1. So the answer is 5 PS 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 and multiplied by 6p1 is just 6 is equal to 5 fours are 20 into 360 into 2 120. It is totally it is 720 ways. So in this problem capital 6 periods in each working day of a school. In how many ways can one arrange 5 subjects such that each subject is allowed at least. Each subject is separate. There is no grouping in this. Each subject is allowed at least one period. So it's a permutation of 5 subjects in 5 periods. The sixth, however, it can vary in 6 ways. So it is 6p1. So we'll move to next problem. A committee of 5 is to be formed out of 6 men and 4 women. A committee of 5 out of 6 men. In how many ways and how this can be done when first is at least 2 women are included. Two is at most 2 women are included. So what's the difference? At least 2 women means it can be 2, 3, 4. At most 2 women means only either 1 or 2. So the first part we will take at least 2 women. It's a combination of 2 women. First is a committee is 5 is we form out of 6 men and 4 women. First let us see the ways of selecting ladies. First we have to make 2 portions in this problem. Number of ways of selecting women. So for each way of number of ways, you can make one more column. What about men? Similarly, what about the total number of ways? So we will take the first portion. So at least 2 means out of 4, 4 combination 2. So what the problem says? How many ways this can be when at least 2 women are included? 4 combination 2. So there are 6. Then what about men for this combination? It should be at least out of 6. Its combination 3 men. See, this 3 plus 2, you are getting a community of 5. This is R, a community of 5 is 3 plus 2. Men total available is 4, 4C2. Women available 6, 6C3. So if we have to combine these two, so total number of AC is 4C2 multiplied by 6C3. 4C2 means 4 multiplied by 3 divided by 2 multiplied by 1. 6C3 means 6 multiplied by 4 multiplied by 4 divided by 3 multiplied by 2 multiplied by 1. So we will cancel the common factors. It is 2 multiplied by 3. 6 5s are 30 multiplied by 4 is equal to, it's 120. So what is the problem says? At least 2 women. At least 2 women. So it can be 3 also. There is way of doing this. So you take 4C3. If you take 3 women, what about here? Men. Out of 6, you have to select only 2. 6C2. Instead of here, the total is 3 plus 2, 5 people can be selected. Here, it will become, men will be less now. What about this product? 4C3 multiplied by 6C2. 4C3 is 4 divided by 4 combination 4, 3, 2 divided by 3, 2, 1. These will get cancelled. So it will be just 4. 4C3 is just 4 multiplied by 6C2. 6 multiplied by 5 divided by 2 multiplied by 1. So we cancel 3. 3 5s are 15. 15 5s. 15 4s are, it is 60 ways. So we have taken the first with the 2 women. He says at least 2 women. So it can be 3 women or 4 out of 4 also it can be. What about 4C4? If you take 4C4, then this will become 6C1. 6 combination 1 is just 1. If you take all 6, it is 1. What about 4C4? 4C4 is 1. 6. So let us, what is 4C4? It is 1. 6C1. This 6C1 is 6 is equal to 6 ways. So totally if you add, it is 186 ways. At least in this case. Now please repeat the problem for at most 2 women. So at most 2 women, what is the answer? Let us. So what is the meaning of at most 2 women? Maximum 2 women. So what is the first one? So the 4C2, the same 2 also can be there. At most 2 women. So we know it is 120 ways above given. So it can be 4C1. When they say at most over 4C1, then when can be? It is 6C4. 4C1 is 4, multiplied by 6C4 is 6, multiplied by 5, multiplied by 4, multiplied by 3, divided by 4 is 4, multiplied by 3, multiplied by 2, 1. So this 4, 3 will get cancelled with this 4, 3. This 2 will get cancelled with this 3. 3 5s are 15 into 5 is 4 is again, so it is 60 ways. So can it be 4C0? Yeah. 4C0 is 1, multiplied by 6C, 5. What is this one? This is 1. 6C5 is 6. It's just in 6 ways. So if you work out these 3 also, you get the same answer. Next problem. How many cards can be drawn? Please repeat this problem because I want to leave explaining this. So you try to apply your mind and repeating. You write the full formula. You can write the full formula. So what is the formula? Factorial n divided by factorial r multiplied by factorial n minus r. Apply this formula and repeat the lesson so that the exact, for example, if it is 4C0, here n will be there, this will get cancelled. Factorial r is factorial 0, this one, so it is just one 6C5 means, for example, whatever n is 6, it is factorial 6. For example, we'll take this case 6C5 factorial 6 divided by factorial 6. Factorial r is that, so it is factorial 5. Factorial 5 factors will go, only 6 will remain in this. Next is, it is factorial n minus or factorial. N is 6, r is 5, factorial 1 is 1. So it is answer is 6. 6 ways. So next problem, and how many cards can be drawn to 20 points on a circle? So in how many ways the cards can be drawn? So the number of cards which can be a card with combining 2 points. So is equal to 20 combination 2. You have to connect 2 points, make a 20 combination 2. So 20 combination 2. What is the formula? Factorial 20 divided by factorial r is factorial 2 multiplied by factorial 18. Factorial 20 divided by factorial 18 is factorial. This becomes 19 multiplied by 20. Only those two factors will remain. Factorial 2 is 182. So 2 if you cancel is equal to 180 cards. What about this one? This is factorial Formula is factorial n divided by factorial r multiplied by factorial. So 2 cards at a time. So with this we have come to the end of this lesson. Thank you for listening to this lesson. Please go through the problems again. This combination and permutation problem, you have to repeat, particularly the problem 4, what is exactly it says. So you please read the question 2 times and connect it with the answer. Each line you must satisfy yourself how many number of ways whether the calculation is correct. So you will have to repeat the problems to get to the exact meaning of the combination. Thank you.